Hi, I'm Wojciech Lešner from Museum of Prague, and today I'm going to talk about data visualization of art collections. And more specifically, I will be talking about multidimensional compressions and how we can enrich our existing database with AI metadata. Currently, we are using existing database in Museum of Prague, and you are probably in similar situation. So we have database that has, for example, author. It has the year when the artifact was made. It also features things like, like a technique or material that the artwork is made from. And these metadata are nice, but also maybe we can do more. We also have, dimensions or maybe a description of the artwork that can differ a lot based on the artifact. So first of all, what we want to do basically is we want a way to see what we already have in a database. And that's already kind of a problem. Because how do you visualize all the stuff that's in the database currently? So maybe your curators or archaeologists or historians, they know what's inside your database. But if you have a new people coming or you want to kind of share it with a public sector, then they have no idea, right? And if you don't know what you are looking for in your current database, it can be really a challenge. And so for that, the perfect tool is multidimensional compression. And basically what you are seeing here on the screen as I'm talking, I'm using a RealSense 3D camera. So I'm kind of like plotting the 2D image to the 3D space. And in this case, I'm taking something that was previously 2D and making it multidimensional. But with our art collections, we can do the opposite. So we can take this multidimensional space that we have that is formed by all the metadata, right? So the author, the year, the material, and all this metadata that we already have in database, we can think of it as parameters, as a coordinates in a multidimensional space. And that's a key, to unlocking, to get a grasp of what you have in your museum or what you have in your gallery, and to give a quick overview to other people. So what this multidimensional compression does is that, it can display the similarities between the artworks based on the distance. So we took all these dimensions, the year, the author, the material, dimensions, descriptions even of the artworks, and we kind of like compress them into only 3 dimensions. So we have like 3 metadata that doesn't really, tell you anything specific. So they don't mean anything on their own, right? But they are kind of like the amalgamation of all the metadata that you previously have in your higher dimensional space. So we took all this like high dimensional data that you already have in database and just make 3-dimensional data from it. And here's the cool thing. So since it's 3-dimensional, we can just plot it in the 3D space. And then you can, directly explore this in your web browser. So you can plot it in the web browser, and the distance between the artworks kind of signifies the similarity between the artworks. So already, it will produce some kind of clusters. So you have these groups of objects that kind of like have something in similar. You don't know exactly, what they have in similar. That's kind of like left for your interpretation based on what you know and based, of your exploration of the data. But it's telling you, hey, these objects that we have in our database, they are probably kind of related. Maybe because of the year, maybe because of the material or the author or the style they are made in. And, more of the parameters you already have in the database, more useful this is. And another cool thing is that it's interactive. So you can, select each metadata that will form your three-dimensional compressed space to, choose what the similarities are based on, right? So maybe I'm only interested in the similarities in the year, or maybe I'm interested in the author and style and description, and this will give you the option. So the algorithms to use for this, it's called t-SNE or UMAP. So these are like one of two most used multidimensional compression algorithms. And that's exactly what we did. So we took a t-SNE algorithm and let it run on the database. And it will produce this kind of like a 3D space that you can explore. And then, you can see what these things have in common between each other. And that's kind of like the main idea. The problem in reality is that, yes, like we have our database, but it's not really machine friendly, right? So we have like some kind of existing software and it's proprietary and we pay a lot of money for it each year, but we don't really own it. And it's really hard, to take data from it. So the first step I took was I needed a copy of this database, but now in a machine learning friendly format. So in my case, I chose, MariaDB. It's like a SQL-based database, and MariaDB specifically because in the newer versions, it also allows for vectors to be stored, and we will need that later. But for now, I just needed a copy of the database, right? So I can, run some other script to prepare the data for the multidimensional compression, so I can finally, in the last step, I can visualize it in the 3D. And that was my journey, right? So first of all, I find out, okay, we have this problem, we have some existing database, but we can't really, take the data from it. So first we need a copy. And it wasn't actually that bad because, having a copy, it's a good thing because you don't mess up your original database. So you can, safely work on a copy of your database and your archaeologists don't go mad and you can't screw things up, or, you can, but you will screw your own copy. So you are not, changing anything in production. So that's important. That's cool. But then I, realized we have a second problem, and that is, some of our data in our database are not very, well structured, and that's a problem. That's a problem. So we have, for example, in our date field, the metadata for our like year when the artwork was made. Sometimes it was a number, sometimes it was a word like a 19th century, sometimes it was a combination of these things, sometimes it was just written, unknown. So, it depends on the database you have, the accuracy of the data that you currently have, but this is a necessary step. So we need to somehow clear this up. And what I did is I did another column that I add into the database where I, for example, converted all the, year that was, kind of written as a word to a number. So it's more easy to work with in this, AI learning space or like multidimensional compression space. So, this would be, like years work, but if you know what kind of type of weirdness you have in your database, you can kind of program a normal heuristics for it. So I just, program a script that will take, if I have 19th century, 20th century, etc., and just turn it into the year based on a little function I have. And then I have another function, if it's unknown, maybe write -1. So, maybe that's a bit example because we can have negative years. It depends on the system that you kind of develop for it. But the point here is we need to kind of filter the data. So there is some work associated with that. Even if you are using scripting to, achieve this fast, it will still take some time. Another problem I was facing was that, maybe you have a copyrighted material. Maybe, the copyright for your database is not clear. And so for that reason, to kind of try this out, I first took already publicly available data that we had that was featured on other websites or on our own website. So I was sure, okay, hey, these things are already public. They were public for some time. So it's probably okay to use it for our experiment here. So that's what I did. So I did I created a crawler that was downloading all these, data that was anyway ours, but I needed a way to get them in this machine-friendly format. And, like you can see, I did some program for this, but basically that's what all the big companies are doing, but without your agreement right now. So all the OpenAI company and Google and Meta, they are downloading this stuff from the internet and they are not asking people. At least here we are downloading our own data, right? So, that's fine. And so, for example, I took some of our parts of our database from a Slovakian, public website to get it. And the cool thing about this is that once you have the final result, the 3D compressed space, then people can understand it intuitively, because we kind of like explore stuff in 3D space. That's where we live in. So we are good at it. We are good at, spotting some similarities, differences, exploring. It's fun. So that's why I chose this. And for example, here on the picture, to showcase it more clearly, you can see the 2D version of this compression. So we are not compressing to 3D, but to 2D in this case. And as the data set, I have chosen just like a handwritten numbers, right? So, and you can clearly see we have these groups of data that kind of are forming these clusters. And so each of these clusters is a number that's associated. And this is like a very, easy example, because in reality, in museums, we have like much more complex data, but it kind of like proves this works. And then again, it's not like, it's just enough to use, this machine approach. We still need educated people that are qualified to kind of interpret the results, to interpret this 3D space. So the curator is still needed to kind of, know what's important in the data set and to get these new ideas, maybe, like what our next exhibit can be about. And so they can look at your data, they can explore it in 3D, and suddenly they are seeing maybe, previously unheard of similarity between some old artworks and maybe more modern ones, but they have something in common. Maybe there's some pattern repeating itself. And since it is interactive, this is a really powerful tool, right? But I didn't want to kind of like, finish here, even though it is nice. What we can also do is that we can add new metadata into our database. So for example, we can run AI algorithms that are detecting, face features. Right? And we can detect faces in our paintings, or in our sculptures, and we can use that again in this like multi-dimensional compression to see similarities. Maybe we can see similarities in faces, or in painting styles. We can also analyze colors. That's super important as well. But for example, these faces also kind of allow all other funny interfaces. So for example, here we have a face swap. So that's kind of like a side product of our exploration of the data set. So now we can kind of offer to the public to try on faces that exist in our database collection, and they can explore it this way. Or we can even like find a similar expression of your face to some our painting there. And it's not limited just to faces. We can also do body pose, so we can see how people are standing in the paintings, and we can map it to your pose. And again, we can also plot this 3D similarity that I was showing earlier. And this is really nice. What's even better is that these AI tools, in this case, this is Google Media Pipe, it's very performant. So you don't need, expensive data center or some supercomputer to run it. If you have some external GPU, you can run it on a single PC. And since you don't need it really real time, you can just run it, overnight or over a week, and it will be done. And so you don't even have to pay some other, providers to, get the hardware, etc. The benefit of that is also that, you can sleep safe in knowing that your data are not leaving your institution, and you have all the rights to it. So you are not, putting it anywhere else. Nobody else can see it if it's running on your PC in your own, local network. And again, this is just like a funny example. So we can also like take pictures and kind of like animate them, but this is more for just like, to engage public or maybe for marketing, not really for to getting insights. We also have to be careful in a way how we interpret this, as there can be some inaccuracies. But basically, what we can also do is to generate a description of the artwork. So maybe you have, some part of your database are missing description. You can use AI model to generate the description for you. This is a little bit tricky because, usually these models were trained on, for example, Instagram posts, or they are describing what they're seeing in this Instagram post style. So the question is how, useful it is. But it still might give you some insight. When you compress it with a multidimensional compression, you can see relative similarities. So maybe the description itself, it's not that valuable, but now you have like one more parameter to run your similarity search on, and that still might be worth it. And to conclude, I think like we can, take our databases to the next century. I think this is a must. This is a step that we all have to do to kind of like, enrich our database with AI metadata, such as, face features, body pose, artificial descriptions. You can, analyze colors and other stuff. But also, in order to be even able to do this, we kind of like need to sort through our data and, clean them so they are easily interpretable. In other words, we have to make numbers from them. And that also means we have to somehow like unify the data. So this is the first step that will be needed in any case. Even if you hire somebody or buy some existing product, like this is a work that you have to do anyway. And honestly, like nothing will, nobody will do it for you. So unfortunately, this is part of our work and the challenge. But still, we can automate this with handwritten scripts that are customized to your own collection. And that's what we are doing at the Museum of Prague. We are also offering this to other museums that we, collaborate with in like a pilot projects. And we are, non-profit. So our the main motivation is not to make money, but is to kind of like share the knowledge, share the know-how. It kind of makes sense to collaborate on the project, and more institutions, will get on this, the easier it will be. Kind of like make your database machine friendly and use this multidimensional compression. You will also kind of encourage independent researchers to work on your collection for free, right? So if you have a nice data, maybe some researchers and academia will use it to, try new things with that and maybe find some interesting insights that you also want. So I think there's a future in it. And my last hot take for this presentation is that I want to kind of, create API for our database, for our art collection, so that it can be used in other people's chatbots. So, I kind of like expect that everybody will have their own chatbot in their phone or on their own PC, and it doesn't really make sense to kind of like create a custom one for every website or every institution. So I think it kind of make more sense to provide an API for the chatbot that the user already has that will enable it to search in your database. So I would love to hear your thoughts on that. Thanks for your time.